Hello everybody, my name is Kai Wehner and I work as technology evangelist for TIBCO Software. Today I want to introduce to you Project Flogo, which is an open source IoT integration project. This is no detailed instruction on slides, so let's really go into live coding in this recording. And I want to show you the source code and the development environment. Flogo is available in the meantime on GitHub, and we are the community page, and here you can access it, as you can see on the top left, via flogo.io, and here you can go to the documentation, to GitHub, to the community, and so on. I really want to focus on the code in this demo, so let's first go to the web IDE, which you usually use later to design your Flogo integration flows. However, I have to also highlight that the Flogo web IDE is not open sourced yet. It will be available in the next few weeks for free to download, and I will show it to you for easy understanding of what the Flogo flows are, and I will also show you the open source code which is available on GitHub already. So here you see the web IDE in the end, where we will design our integration flows. Of course, you can also write all the code just with a source coding and another coding IDE. Here I use my designer later, but let's first show you what is running here in the background. This is in the end a Docker compose command, which starts my Flogo containers needed for the development. And what I have here, I have in the end 4 different containers which are already running. Let's do a Docker PS. And here you see we have the Docker runtime and 2 services which are supporting the runtime, the state service and the flow service. And we also have a Redis key value store for storing information. That's basically what is running in the background. And after you have started Flogo via the web environment and IDE, you can start developing your processes. There's also a configuration overview where you see if all your engines are running, and here you then also have access to the logs for detailed debugging and so on. I want to here show you first a hello world example before we go into more advanced use cases. So for that I create a new flow, and let's say this is really a hello world example, and I save it. And what you can now do, you can now edit that and code your flow. So if you have seen other integration solutions for visual coding, it is pretty similar, but the goal is in the end to be much more lightweight and really create IoT edge apps or serverless flows, which are very, very less memory consuming than the typical Java services also. In this first example, I really just want to build a hello world with a timer trigger. This trigger here starts a new flow, and after that I do a log, and therefore you see how the basic development works. You select your triggers which initiate new flows, and then you use other activities like logging or filtering, and then all the connectivity to MQTT and CoaP, or other technologies like REST invokes or something like this. And here, this is a very basic flow. Here I just type in hello world, and then I run this flow here. Now you see it's already completed, so because the runtime is written in the Go programming language, it's very efficient and you can execute and compile and start your flows very quickly. So here you see the blue color, so this one was successful, and therefore also we see the output here. So this is really a very simple hello world flow, and we also want to take a look at more complex detailed flows. Therefore, let's next take a look at a weather service which I already implemented. This one is already a little bit more complex, and what I do here, I implement a REST service so that a service consumer can call it, and then with the parameters, which in this case is the city where I want to get the information for, then I do some logging before I invoke the external weather service, which here you see the URI, and you see the path parameter. In this case I want to know the weather for Nuremberg, and then I log this information again. So we can execute this flow in the same way, run from trigger first, And after a few seconds, it's executing this flow, and we will see here now it's completed the execution, and here you see all is blue. So there was also no error, otherwise the flow would go to the error handler, where you could also implement some error logic here. In this case, I do not have one. I was just interested in some weather information, and here now you see the weather information for Erlangen, which is here with 12 degrees Celsius, for example. So what's important here is, besides designing these triggers and the flows, you also have to configure the transformations. And to do that, I click on one example, and what you can do here, you can configure the transformations from the output of the previous activity and how you get information to the next activity. And therefore here you can select which parameters you want from the left side and click it, and then also do transformations or select just specific parameters or something like this. And then this is typically how you develop such a flow. And after you have developed it, of course, you want to export it somehow and build it. And therefore, as I said, the runtime is built on Go, which is a very lightweight engine. And therefore, the main goal is that you really can deploy it either on very lightweight devices, really not just the typical Raspberry Pi example, but really the really small devices and even sensors. Though this runtime and engine compile stuff which is much, much smaller than, for example, a Java or JavaScript application which generates code. And in this case, for example, here I use the Darwin example, though, that I generate a final binary file which I can execute here for testing on my MacBook. I have already done that, and let's go to my terminal here. So here you see I've already created a few different binaries. And then you can simply start, in this case, the weather service. And as you see here, it takes a few milliseconds to start. So not just the compilation time for Go is very fast, but also then the execution, and it's a very low memory, which is another benefit in the future where you have to do so many computations and execute many distributed microservices in a world of Internet of Things and cloud and serverless and so on. So this service is now waiting here for my service request. So I can simply go to a web browser. In this case, I'm just returning here the ID of the flow, so not much more information, just to see that it works. And if I go back now to my console here, now you will see that you get here the logging information, and this also includes now the weather for Erlangen, which I have typed in. So this is an example of how you build a Flogo flow and then also export and run it, even on very small edge devices. And now let's take a look at another example. First, I have here an MQTT example. This is just to show you instead of a trigger or REST service, of course, you can connect to anything which is a connector available already, like MQTT or CoaP, and it's very easy to build your own connectors. So Flogo is open and it has an API and SDK, and therefore it's really meant that you build your own connectors and so on with this open source engine under the very permissive BSD open source license. I want to finish with one last more complex example, and here I want to use, you see here, a pet API. So this is the API which is offered by Swagger, which is more or less the de facto standard for REST services, and many vendors are using this. And therefore I choose this example because then you can also try it out by yourself easily when you want to try out Flogo later. I just want to use the pet API. And if you take a look here, for example, at the get a pet via ID example, you can enter here, for example, pet ID 222, and then try it out. And then you see here the response, which is the pet with the name 222 UX doggy. Okay, so this is Swagger and using its REST service. And if we take a look back at our Flogo implementation, this is initiated by a REST call and does some logging. And then you do a query for exactly this pet API via the GET request. And here you see I'm having the URL and my parameter with 222. And depending on the return response value, you do different routing and condition-based execution. So here, if I get a code 1, then that does mean there is no pet existing, and therefore I create it here via another REST call. And otherwise, if it is already existing, which is 222 as the code, then I will delete it. So we can execute this to understand it easily. I run the trigger. From the trigger, you see the flow is already completed. And you see here the flow, because it was already existing, as we saw here in the Swagger test. Now we deleted the pet. And we can double check that if we go back to Swagger. And if we try out again the REST API here, we now will see that the pet is not found. So now we can create a pet again. And what's now important is one cool feature of Flogo is the what we call step back debugger. So that means you do not have to restart your application or compile everything again. Here you can really use to development without recreating everything all the time. And that saves a lot of time and makes it much easier, especially in more complex processes. So in this case, I can also just start from this activity. And here now I can select run from tile, and therefore it's starting just from this activity and checks does the pet already exist. In this case, of course, no, and therefore now we create it again. And if I can check here with the Swagger API again, now you see it is back here. And in this way, you can easily take a look at all the log information and the parameter values. It's really like a typical debugger, but very easy because you do not have to restart everything and can move back and forward and restarting just parts of the application. And that's basically how you do really IoT development, because this way you could also easily connect to remote devices and debug on the device itself. And that's some pretty cool features which you can use here. That's basically my short overview about development with Flogo, but let's also take a look at the source code for a minute. So here we see the code I have already exported. We can first go to GitHub for a minute. You see here the source code is available under tipcosoftware/Flogo. And right now we have 4 projects available, which I will show you in a minute. So there is the command line interface where you create your applications and do things like DevOps and continuous integration. You have the Flogo lib, which is your core engine. You have a state and a flow service. These are baking services which are used by the libraries. And you have a Flogo contrib folder. This in the end is the connectivity and triggers and activities. Some are already existing, and of course there will be more and more. And you can of course also create your own, and we would be happy if you can do a pull request for that too. Here in this case I use Light IDE, which is a Golang supporting development environment, but of course you can also use Eclipse or text editor or whatever you want to use. First, a short look at the core. Here really this is the implementation of the engine. And for one example, you see here the runner, which can be a direct implementation or a pooled runner or a worker runner. And this basically means how the flows are executed later. So the other one is the Flogo services. Here you see the state service and the store service. These are, as I said, used by the core engine. The contrib is the one where you have all the activities and the triggers and so on. As you see here right now, the number is a little bit limited, but this number of features will of course increase soon. This is the first release, you have to remember, of Flogo in October 2016. And here we can maybe take a short look at one implementation of an activity for the REST example. And here now you see that here we leverage all the other Go libraries for I/O and for network communication to implement the invoke REST activities and so on with them constants. And this now is some Golang code which you can dig into if you are interested into that. And then finally, here we have the CLI, so the command line interface for doing the automation and scripting. And as you see, also that is implemented in Go itself. So here, for example, you see the commands which you use in your Flogo command on the command line to add new flows or to build your flows, to do configuration and all these kind of things. And as you see, all of that is also implemented in the Go programming language. So this concludes my short introduction to Project Flogo from a coding perspective, showing the web IDE and also showing the source code a little bit. And now you can get started with that by yourself if you're interested. Thanks a lot for watching.